Welcome everybody. In this lesson we're going to be talking about binomial probability, and first thing we want to talk about is something called a probability distributions. Now, probability distribution is a distribution in which the probability for every possible outcome of an experiment is listed, and it turns out the sum of these probabilities will equal 100%. So it's basically almost like listing out the sample space, but instead we're listing out all the probabilities for a given experiment. So in our first example, it says give a probability distribution for each experiment. Show that the sum of the probabilities is 100%. So our first example is a coin is flipped. It's just flipped one time, and so we have our two possibilities. We have heads or we have tails. So what we want to do to write an actual probability distribution is list all the probabilities of all the possibilities. So the probability of getting a heads is 1/2 or 50%. And then the probability of getting a tails is 1/2 or 50%. Now that's everything, and you can see here if we add up the sum of the two probabilities, we get 100%. Let's try our next one. So a normal 6-sided die is rolled. So we can get a 1, a 2, a 3, a 4, a 5, or a 6. So the probability of getting a 1 is 1 out of 6. Probability of getting a 2 is 1 out of 6. Probability of getting a 3 is 1 out of 6. Probability of a 4, 1 out of 6. Probability of getting a 5 is 1 out of 6. And the probability of getting a 6 is also 1 out of 6. So when we look at this and we add up all the probabilities, we do get 1 or 100%. So these were just a single experiment, single event here. And now we're going to try multiple events. So our next example says a basket contains 3 marbles, 1 red, 1 blue, and 1 yellow. 3 marbles are to be selected with replacement. Give a probability distribution for selecting a specific number of red marbles. Okay, so as we're looking at this, we are pulling out 3 marbles. And so the possibilities that we could have here are the number of red marbles selected. So we could get 0 red marbles, or we could get 1 red marble, or we could get 2 red marbles, or we could get 3, all 3 red marbles. So the question changes just a little bit based on how many we can actually get. So, being the nice teacher that I am, I have made a nice little tree diagram of this experiment for you. So you can see here the first marble, we can choose red, blue, or yellow. And then branching off, our second marble, this is with replacement, so notice we can get red again here, we can get blue again here, and we can get yellow again. And then for our third marble, again, all of our choices are available. So we know this is 3 times 3 times 3 for 27 possibilities. And here is a listing of our entire sample space, all 27 of them. So let's go ahead and find all the possibilities of selecting the red marbles. So what's the probability of selecting 0 marble? 0 red marbles. Okay, so we'll just come down. Let's find the ones that don't have any red. And then we'll count them up. Should have gotten 8. So it's 8 out of 27. We'll do the same thing now with getting 1 red marble. Okay. Now this 1 is exactly 1. So we're looking for exactly 1 here. Here. All right, I think that's all of them. Let's go ahead and add them up here. I come up with 12. So there's a 12 in 27 chance of getting exactly 1 red marble. Let's try getting exactly 2 red marbles. I'm just going to identify them all. I think that's all of them. So 1, 2, 3, 4, 5, 6. And our last possibility is getting exactly 3 red marbles. And if you look, that's our last one left. There's only one way of getting exactly 3 red marbles, so 1 out of 27. Now again, we do want to make sure that this adds up to be 100%. You can see that we've marked every item in the sample space, and if we were to find the sum of this, we have 8 plus 12 plus 6 plus 1 is 27 out of 27, and there is 100%. Now we're going to move on and talk about the binomial probability formula. And what this is saying here is the probability of getting exactly x successes in n tries is ncx times the probability of success raised to the number of successes times the probability of failure raised to the number of failures. So let's go ahead and write down what each of these things means here. So the probability of x, so px, in this case, it's going to stand for the probability of getting exactly x successes. So that kind of tells us what x stands for. This is the exact number of successes. N is the total number of trials. P is the probability of success on one trial. And then Q is the probability of failure. On one trial. Okay, so you can see here our x shows up a couple places in our formula. And n also shows up in 2 places. Okay, this p right here is a lowercase p. That's right there. And then we see our q and the q right there. Now, it turns out that the probability of success and the probability of failure adds to 1. Okay, so either something happens or it doesn't. Now in the formula, it's interesting to note here that this x at the top, that's the exact number of successes we're looking for. And when we take n minus x, that's actually the number of failures. And you might be thinking, what are we going to use this for? And it turns out we can use this formula to answer any one of these probability problems without needing to do this. Okay, don't need the tree diagram, don't need the sample space. So, when can we use the formula? Okay, we can use the formula when there are n independent trials. So remember, independent means one does not affect another. So rolling a die, flipping a coin where the experiment doesn't change, or when you have with replacement. Now each trial has to have only 2 outcomes, and we measure the outcomes as either being a success or a failure. So either the event happens or it doesn't happen. And it turns out that the probability of success or failure must remain the same for each trial. So it doesn't change one trial to the next. All right, let's go ahead and try a couple examples here. So example 1 says a normal 6-sided dice is thrown 5 times. What is the probability of getting the number 1 3 times? So we just need to find a couple things here. We want to find n, the number of trials, which in this case is 5. We also want to find the probability of success. Well, what are we looking for? We're looking for getting the number 1. So to get a 1 on a 6-sided die, the probability of success is 1 out of 6. The probability of failure then, okay, is everything else. So if this is 1 out of 6, failing is 5 out of 6. Remember, these add to 1, and so we're good to go right there. Now the last thing we need to find is x. And x is exactly how many 1s we want to get. And we want to find this exactly 3 times. So we're going to write this as getting the probability of getting exactly 3 1s. And just using our formula, it's NCX, so 5 C3 times the probability of success, 1/6, raised to the number of successes, which is 3, times the probability of failure, which is 5/6, raised to the number of failures. Okay, so here we have to do a little bit of math. If we're going to try this thing 5 times and we want 3 successes, that leaves 2 failures. Now we're just going to type this all into our calculator. So we want NCR, so 5, math, PRB, NCR, 3, times, now 1/6, we're going to put that in parentheses, and then raise it to third power, and then in parentheses 5/6, raise that to the second power, or you can hit the squared button. Now, does it matter if we put parentheses around 5 NCR3? Let's go ahead and see here, because in our formula we had parentheses. Okay, and it turns out it doesn't matter, so we're good to go either way there. And here we have 3.2%. All right, our next example is going to look pretty familiar. It says a basket contains 3 marbles, 1 red, 1 blue, and 1 yellow. 3 marbles are to be selected with replacement. Okay, so this is the same example that we did on the first page with the sample space. So we're just going to see that this binomial probability formula does work for solving these. So exactly 0 blue marbles. Well, first off, just based on the problem, n is going to be our number of trials, so that's going to be 3 for all of these questions. The probability of success, well, we're looking for blue marbles in all of these, so that's going to be 1/3. And the probability of failure then is 2/3. So if we're looking for exactly 0, x is going to equal 0. So the probability of 0 equals NCX, so 3C0 times 1/3 to the 0 times 2/3 to the 3 minus 0, which is just 3. And again, we're going to try this in our calculator here. So we need 3, math, PRB, NCR, 0, times 1/3 in parentheses, raised to the power of 0, times 2/3 in parentheses, raised to the power of 3. Now it gives you 29.6%. Let's go ahead and use mathfrak, our favorite, and we get 8/27. If we look back at the first page here, sure enough, 0, we did get 8/27. So now that we know what we're doing, we can do the next couple very quickly. So x equals 1, p of 1. The only thing changing here is x. So we can use our calculators to our advantage right here. Since we've already typed this all in, we can hit second and then entry. And do that again, second entry. And we can go back through and just change a couple of these numbers. So now we want 3C1 raised to the power of 1, and then 2/3 squared. And then math frac, we get 4/9. Our next one, exactly 2 blue marbles. Go ahead and just try it along with me here. And you should get 2/9. All right, and our next one is exactly 3 blue marbles. So what does x equal? Should be 3. Now when we look for P 30, okay, write out your formula there. No, I almost wrote 0. And we'll go back through and change these. And we do get 1 out of 27. Now if you look here on the other page, I think these are exactly what we just got. Okay, 6 out of 27 is 2 out of 9, so we're fine there. 12 out of 27 is 4 out of 9, so we're fine there. Now our next question throws kind of a twist in things. It wants to know the probability of at least 2 blue marbles. So the word at least 2 means to us 2 or more. And what that means is 2 or 3. Because or more in this case only can go up to 3. So what we're going to do here is let x equal 2 or x equal 3. And if you remember our OR formula, this is the formula where we have to add. So anytime you have an at least problem, you're going to look for the ORs, that number and higher, and then add them together. So we're going to find the probability of getting exactly 2 plus the probability of exactly 3. And fortunately, we've already done these. Okay, so the probability of exactly 2 is 2/9. And the probability of exactly 3 is 1 over 27. Okay. We already have 1 over 27 in there, so we can just hit plus. And then 2 over 9. Don't need a fraction button, you just use the divided sign. And then math frac, we have 7 over 27. Okay, so we're moving on to our next example. It says if you flip a coin 4 times, what is the probability of getting at least 2 heads? So looking at this, n is going to equal, how many times are we flipping the coin? 4. The probability of success, well, on a coin, getting a heads is 1 out of 2. And then probability of failure, or not getting a heads, is also 1 out of 2. Now this question says getting at least 2 heads. So when we find our x, we actually need to find x equals 2, or 3, or 4. And that tells me we're going to find each one of these probabilities, probability of exactly 2, plus probability of exactly 3, plus probability of exactly 4. Okay, so we're going to have to write out this formula a little bit here. So the first one is going to be 4c2. We can use 0.5 for 1/2. And we're getting 2. And if we have 2 successes, how many failures are we looking for? Out of 4 tries, so 4 minus 2 is 2. Then plus 4c, now we want all 3, or 3 out of 4. And we want 3. So if we have 3 successes, that means we're going to have 1 failure. And then 4c4 means we're going to have 4 successes and 0 failures. Alright, I don't want to spend more time typing this into our calculator than we need to. We'll just write all this out. Turns out that we end up getting 68.75%. Okay, but the biggest thing is for at least 2, that means 2 or 3 or 4, add up all 3 of these probabilities. Now our next example, the probability of finding a peach in a box with a scratch on it is 0.05. So I used to work in a packing shed, and I'd stack 50-pound boxes 7 feet high all day long, and inspectors would come to inspect the fruit. And so they would just randomly select a box, and they'd go through every piece of fruit to see if they were good fruit. And what happens is if you find too many scratched fruit in a box, they figure, well, maybe all of them are like this, or a good number of boxes are like this. And so what we'd have to do is we'd actually have to rip open all the boxes that we had stacked, put them back on the conveyor belt, and they'd have to repack them. So this problem comes a little bit out of my past a little bit. So the probability of finding a peach in a box with a scratch on it is 0.05. In this example, they give you P, which is very nice of them. So you don't always have to find that. So if P is 0.05, Q is 1 minus 0.05, which is 0.95. Now it says find the probability of finding exactly 2 scratched peaches in a box of 50. So when we think about this, N is going to be 50 for the 50 peaches in the box, and X is going to equal 2 because we're looking for exactly 2 scratched peaches. Alright, so the probability of 2 is 50C2 times 0.05 squared times 0.95. Okay, this is failure, so the number of failures is going to be 48. Because 2 and 48 make 50. And we'll try this in our calculator here. So 50 C2 times 0.05 squared times 0.95 raised to the 48. And here we get 26.1%. Now it's really good to know this formula and be able to use it. And please don't hate me, but now we're going to see how the TID3 can become a very powerful tool in finding binomial probability distributions. So there's actually a function that's going to do this formula for you all at once. And it's called Binom Pdf. And where we find this is in the second vars menu. Let me show you where that is. So here's the vars button. Okay, so there's your vars. And second vars, it's actually dister. And you guessed it, dister stands for distribution. And so now we got to scroll down until we find Binom Pdf. Oh, there it is. And it's letter A right there. So you just want to select Binom Pdf, and then it's going to be asking you for a couple things to put in. What you're going to be putting in is N, P, and X based on the question. Okay, so let's give this a try here. On a 10-question multiple choice test with 4 options per question, the probability of getting 5 and only 5 correct answers, assuming you guess on all of them, is, well, N is the number of questions, so there's 10. P is the probability of success. Well, if there's 4 options per question, the probability is 0.25. Now in this case, you don't even have to find Q. The calculator will do that for you. So you do have to find X, the exact number of successes you're looking for. So here we're looking for 5. Okay, so let's find our Binom Pdf again. It's going to be second vars, which is distribution. We're going to scroll down to Binom Pdf. Then we're just going to plug in NPX. So in this case, we have 10, comma, 0.25, comma, 5. When we hit enter, it gives us the probability in decimal form. We'll just usually change that to a percentage. Okay. So here's what we did. We did Binom Pdf NPX. And it ended up giving us 5.84%. So now we're just going to go through the next 2 examples pretty quickly. A local weather station has been accurate with their temperature forecasts 80% of the time. Find the probability that they are accurate exactly 3 of the next 5 days. So when we're looking at this, N is going to be, well, the number of trials, so 5 days. P is the probability of success. So they were 80% successful. We're going to change that to a decimal, 0.8. And X is the number of successes we're looking for, and that's going to be exactly 3. So again, we're going to do Binom Pdf NPX. So 5.83. Let's go ahead and find it again. It's going to be second vars. Scroll down to Binom Pdf, and 5, 0.8, 3. And we get 20.48%. And our final example, you guys still with me? It's been a while. Whew, I'm exhausted. So here we go. Probability that an individual is selected is 0.4. Find the probability that at least 2 of 5 people selected at random have blue eyes. Alrighty. So here, n equals 5. P is 0.4. Now x, here again, at least 2. So that means x is going to equal 2, or 3, or 4, or 5. Okay, so that means we're going to have to do Binom Pdf 4 times. How fun is this? Okay, what we can do now is start using our second entry button so that we don't have to change everything all the time. So we used this earlier, and second entry, it pulls up our last one. And notice we can do back as many as we want. And then we can just scroll over and change things. So n is 5, p is 0.4, and let's just start with 2. Okay, so we'll just hit enter there. And we'll record that, 0.3456. Then we want plus. So we need to go back in, so second entry, we're just going to change it to a 3. Hit enter, we get 0.2304. Plus. Again, we're just going to hit second entry and go back and change the 3 to a 4. We get 0.0768. Plus, and our last one, second entry, change the 4 to a 5, and we get 0.01024. Now the last step is to go ahead and add all these up. So we got 0.3456 plus 0.2304 plus 0.0768 plus 0.01024 for a grand total of 0.66304 or 66.304%. Alrighty, thanks for hanging with me. And that was binomial probability distributions.